right, today we're going to talk about inverse functions. Okay, so inverse functions are basically two functions that kind of undo each other. Okay, so an inverse function is a function that undoes the original function. Um, the original function. That is not really great notation. Like, I don't know, I can't remember exactly what I meant to write when I filled in this blank here. But that's the general idea here, is that you have a function that undoes an original function. Okay, so like as an example, adding and subtracting are inverse functions because they undo each other. So if you add 3 and then subtract 3, inverses. Okay, here's your technical definition. So a function g is the inverse of function f. So those are just the names of the two functions. This guy right here, this is a common math thing where there's an if with two f's. That's not a typo, right? So that stands for if and only if. Okay, so you write if with two f's, if and only if. So a function g is the inverse of function g, f, if and only if. Whenever y equals f of x, then x equals g of y. Okay, so that sounds confusing. So what it's saying is that when you plug x into function f, the answer that you get, if you plug that answer into function g, you get back to the original number. Okay, so that's all that that's saying. Okay, so let's take a look at kind of what you do for steps here. So the first step that we're going to do is we're going to switch x and y, and then we're just going to solve for y. Okay, so it's pretty straightforward. Okay, so let's take a look at this. So this guy right here, step 1 is we're going to switch x and y, and I literally just mean where the y is, write an x, and where the x is, write a y. Okay, so we're just swapping those two letters. All right, and then I'm going to solve now for y. So I'm going to add the 1 to both sides, and then I'll divide both sides by 3, and I'm going to write that as 1/3 x plus 1/3. All right, I just divided each term by 3 separately. And there we go. That's our inverse function. See, not so bad. Okay, next guy over here. So again, we're going to do the same thing. I'm going to switch x and y. So this is now going to be x equals y squared minus 18y plus 70. All right. So now from here, we have to solve this. So in order to solve this, I need to somehow solve, right, for this y. So I'm going to see if I can somehow do something here, like maybe factor this, or if I can cut, well, factoring is not really going to help though, because it's not equal to 0. So I take it back. We can't factor this. Let's see, we could complete the square. That would work, right? So let's try completing the square so that I can get this y isolated. So what I'm going to do is I'm going to drag the 70 over with the x. So I'll go ahead and do that. Actually, no, I'll just shove it off to the side. Sorry, I'm a little indecisive this morning. All right, so I'm shoving the 70 off to the side. Okay, and now I'm going to figure out what do I need to add to both sides. So the shortcut, remember, is that half of this number squared. So half of negative 18 is negative 9, squared is 81. And since I added it on this side, I'm also going to add it over here. So now I have x plus 81. This I can write as y minus 9 squared plus 70. And now we can solve this. I'm going to subtract the 70 from both sides. So I'm going to get x plus 11 equals y minus 9 squared. Square root both sides. Don't forget when you take a square root, positive or negative. Okay, and then we'll add the 9 to both sides. And there's my inverse function. Okay, notice that we put the 9 in the front. That's kind of common because you have this plus or minus in the front, so it's nicer to write 9 plus or minus a square root than positive or negative square root plus 9. Okay, so that is our inverse function. All right, and then this last guy here, so we want to solve this one. So the first thing I'm going to do is add the 3 to both sides. So I'm going to get y plus 3 equals positive or negative square root of x. Okay. Oop, no, I skipped something. I'm sorry. My brain's all over the place. I forgot to switch x and y. That's literally the first step. There we go. Now we switch x and y. Then I'm going to move the 3 over. Okay. And now I'm going to square both sides, right? To get rid of that square root, I'm going to square both sides. So I'm going to get x plus 3 squared equals y. And that's my inverse function. You could also write that out as x squared plus 6x plus 9. And those are our inverse functions. Okay? And again, just as an example of kind of what's going on, so the point of what an inverse function is that if I plug a number in for x here and get out an answer, and then I plug it into this function, I'm going to get back to the number I started with. So let's start with something pretty easy. How about 5? So 3 times 5 is 15. 15 minus 1 is 14, right? So y is 14. So if I then go to this function, right, and I do, right, 1/3 times 14 plus 1/3, it gets me back to the 5 that I originally plugged in. Okay, so that is what's going on here. So I'm starting with a number, and right, to give you just a solid example, right? So if I plug in 10 into this first function, right, I'm going to get out 29. And then if I take my new function and I plug in that answer, so 1/3 times the 29 I just got plus 1/3. So I plugged that answer I just got back into the second function, and you can see we got back to 10. So the number I plugged in here is the number that came out here. Okay, and it also works the other direction. If I start here with, so if I do like 1/3 and times, I don't know, 20 plus 1/3, okay, I get 7. If I go back to this function and I do 3 times 7 minus 1, I get back to the 20 that I started with. Okay, so it works in both directions. When you plug a number into one, you get an answer, get that answer and plug it into the other one, you get back to where you started from. Okay, that's what an inverse function is. All right, so in order to show that two functions are inverses, we basically have to show that what we just did works. Okay, you have to show that if you plug a number into one function and then plug that answer into the other function, you get back to what you started from, and that it works the other direction. So like what we just did is we said, all right, I called x 20, and we said I'm going to plug 20 into function g. We got an answer 7, so g of x was 7. And then I plugged 7 into function f and got back to the 20 that we started from. Okay, so that's what we have to show works, but we just showed it works for one particular number. We need to show it works for any number x. Okay, so that's what we're going to do here. So in order to show that these two are inverses, we're going to do this composition here. Okay, so for the first one, what I'm going to do is I'm going to find f of g of x. Okay, so what that means is you're going to put x into function g, which there it is. That's x plugged into function g. And I'm going to take this and plug it into function f. So I'm taking g of x and I'm plugging it into function f. So function f says do 3 times whatever you're plugging in. So x plus 1 over 3 minus 1. Okay, and then we're just going to simplify that. So these 3's are actually going to cancel each other out, right? So that'll cancel, and I'm left with x plus 1 minus 1, which is x. So I showed that when I take g of x and I plug it into function f, I get back to x. Okay, so that works. But now we have to show that it also works going the other direction. So we're going to do the same thing, but now I'm going to find g of f of x. So that means I'm going to take f of x and plug it into function g. Okay, so function g said to do whatever the thing is plus 1 over 3. Well, the thing is function f of x. So I'm doing 3x minus 1 and then plus 1 over 3. Okay, well, minus 1 and plus 1 cancel each other out, so that's 3x over 3. And that simplifies to just x. So that also works. Okay, and therefore, we can decide that these two are inverses because it works in both directions. Okay, so they're inverses because both are true. Or actually both simplify to x, I guess. Okay, so if one of them didn't, then they wouldn't be inverses. It has to work both ways.